Okay, so this is a quick review of graphing absolute value and linear inequalities. The couple of videos that you might have just watched were about absolute value and linear equations, which is actually what I have up here in black with an equal sign. But what we're doing today are things that have less than or greater than, or greater than or equal to, or less than or equal to. So it's actually pretty much the same. We're still going to graph the same way. It's just that now we have to be careful about shading. All of these graphs will have shading either above or below the graph that we draw. And then also we have to be careful about our boundary line. Is it dashed or is it shaded? So just as a quick reminder, for a symbol that is less than or greater than versus symbols that are less than or equal to or greater than or equal to, if there is no or equals to, those are going to be dashed boundary lines. And you'll see what I mean in a minute if you've forgotten. And then if there's an or equals to, it will be a solid line. And then we'll talk about shading here in a minute when we do this. So let me go ahead and just get rid of these two guys to make sure that everybody's on the same page. We are doing inequalities, not equations. All right, so our first problem up there is an absolute value. That's the first thing that you want to notice, so that you make sure you make it a V and not a line. If you remember from the absolute value video, this says to start, rather to have your turning point at +1, -6, making sure to change the sign on the X, so +1, -6. And our A value in front of the absolute value is telling us that we are going to be opening up. So our V is going to open up, and it's going to be going up 5 and to the right. Oh, I'm sorry, out 3, because it goes in both directions. So up 5, out 3, up 5, out 3. And then I'm going to do one, actually I'm going to do as many as fit. So up 5, out 3, 5, out 3. And then one more should fit. All right, now before I connect it and make it a solid line, we need to notice that this is just a plain less than. It is not a less than or equal to. So we need to make this a dashed line. So I'm going to just connect this with dashes. Okay, and there is my absolute value. However, I do need to do some shading. Now, since it says that y is less than, if you're thinking about y, the y-axis goes up and down, less would imply down. So one of the ways that I like to do this to make sure that I don't mess up is just kind of circle a couple of points and then go whichever direction that we decided to go. And we said less means down. So I'm just going to kind of highlight down on a couple of these points just to remind myself. And then I know, in case I wasn't sure, that I need to go underneath this absolute value. And that is our inequality. So points that are in the shading but not on the line will satisfy that absolute value inequality if you plug them in. Any points in the shading but not on the line or on the absolute value V. Okay, so on the next one, this one is a linear because there are no absolute value bars. We still have our point here. It's not a turning point, it's just a regular point. Oops, that needs to be a +8. So -3, +8. And then my rate of change is telling me to fall, fall to, as I go to the right, 1. So I'm going to go ahead and do that. And I'm going to fill up my graph just because I know it will help me with my shading. Okay, so then I need to look at my symbol and decide, am I making this solid or dashed? And since it says greater than or equal to, I know that I need to make it solid because of the or equals to. And then deciding where to shade, it says y is greater. Again, y goes up and down, and greater would imply up. So I like to just highlight a couple of points, draw an arrow up from them just to remind myself where to go. And there we go. I know I'm above the line. Okay? So those are just a very basic absolute value and very basic linear. I do want to talk about this, just one case with linears. You know, linears have so many different forms. This one is standard form, which isn't a big deal. It's just if we're going to do standard form, sometimes it's easier to rearrange it to get y by itself, isolate y. And when you're doing it with inequalities, there's just one small thing you have to remember when you're kind of rearranging inequalities. One thing that might trip you up, which is why we're going to talk about this one. If you remember from our linear video that to get y by itself, we need to move the x. Since it's positive, I'll be subtracting it. And actually, I'm going to go ahead and throw in that 1 that's kind of implied in front of there, just to make sure that I'm not making any mistakes and I know what it means. So if I get rid of the positive 1x by subtracting, all I have left is the 2y. Negative 2y is greater than, my linear piece was negative and my constant is positive. And then to get rid of that negative 2y, I would have to divide. Since it was being multiplied, I undo it by dividing. And then here's the part where you might trip up. You have to remember in inequalities when you're solving like this, if you divide or multiply by a negative, so we divided by a negative, you have to remember to flip the symbol. So I'm going to make it a less than. All right, and then what's left is just the y. Negative 1 divided by a negative 2 is a decimal, so I'm going to leave it as a fraction, but negative over negative is positive. And then positive 6 divided by negative 2 is a negative 3. So just have to be careful with that, remembering to flip. In the other videos, if you were watching, you know that I prefer to think about this, instead of in slope-intercept form, I prefer to think of it in point form with that plus 0 in parentheses. So then it's telling me my start point is at 0, negative 3. So I put that in there, 0, negative 3. My slope is telling me to be rising through my start point. I'm going to rise 1 and go to the right 2. So my start point, rise 1, right 2. There we go. I'm going to change colors on my start point. Not that it matters, just kind of like to see it. Okay, and then should we make this solid or dashed? Looking back at our symbol, it's just a less than, no or equals to, so this needs to be dashed. Which sometimes is kind of hard to show, that's why I like to show it out to the side of the graph also. And then we need to decide, are we shading above or below? So if you look back, when we flipped it, it now says y is less than, and since y is up and down, less implies down. So I'm going to just pick some points on my graph, kind of draw some arrows straight down from them to remind myself, and then I know that I'm shading below. So any point that I would pick, any ordered pair that's in that shaded region, but not on the line since it's a dashed line, will work in that original inequality. Just remember, if you divide by a negative, to flip the symbol. Otherwise, your shading will go in the wrong direction. All right, then like in all the other videos, if I give you an equation, you should be able to give me the graph and vice versa. So I'm giving you the graph, you give me the equation. And by equation, I don't mean equation, I mean inequality. So this one is an absolute value. So I know that I'm going to need my turning point, negative 3, and I'm also going to need my stair steps, which I know it's tough to see probably at home, but there are perfect points every up 1 over 1, up 1 over 1 every time. So I know that my slope is 1 over 1. Since this is an absolute value that opens up, we're positive. And that's just the same as 1. So I'm going to leave a space after my y for where I'm going to decide, am I less than, greater than, all of that. I'm just going to leave a space. 1 was my rate of change. My ordered pair was -3, -3, so I need to change the x, keep the y. All right, and then for our shading, I'm just going to grab a point and see that the shading goes directly up from every one of these points. So I know that I am up means greater than. And then do I need to put an or equals to? No, since this is dashed, which again, if that's hard to see from home, I'm sorry, but it is dashed. So I'm going to leave it as just greater than, no greater than or equal to. Okay, let's try another one. So this one is a linear. So it's going to look very similar to the one we just did, except no absolute value bars. We'll do a parentheses instead. Let me go ahead and pick out some nice points. If they're hard to see at home, they're really every down 3 over 1, we have a nice point. So there's our rate of change, -3. I'm just going to pick a random point to use for my point form. That is 2, -5. If you want to pick the y-intercept and put it in slope-intercept form, you certainly may. I'm just going to do point form since it's similar to that absolute value. All right, so my rate of change was -3. Now I'm using parentheses. Let me change the sign on my x, keep the sign on my y of the point that I picked. And then we need to decide what is our symbol going to be. So if I kind of check this out, I'm going to just grab a point and notice that the shading is down from that point. Shading is down, shading is down. So down implies less than. And this is a solid line, so we would say less than or equal to. Okay? And then just one more. All right, so this is a vertical line, and if you remember from the linear video part 2, horizontal and vertical lines are a little different than normal. They do not have both the x and the y in the equation. It's either an x or a y. I do not want you to memorize. I'm not a fan of memorizing. Just grab some points to remind yourself, is this an x equals or a y equals? Grab some random points off of there. So let's see, this bottom point is 7, -6. I also picked 7, 3, and I picked 7, 7. So just looking at that, you can see that every x value is 7. So I know this is an equation with just an x and just a 7. And excuse me for saying equation, it is not an equation. I will not be putting in equals. We need to decide what symbol to put there. And here's where the weird part kind of comes in. On all the rest of them, when we had a y in the front, y goes up and down. So that's why we were kind of checking to see, was our shading up or was our shading down from every point? And again, that's because we had a y in the front of every single one of these. But when we have an x in the front, like this guy, x doesn't go up and down. It doesn't make sense to circle one of my points and draw an arrow up or down. That's not the way the shading goes. The shading goes to the left on this one. So we don't want to draw arrows up and down because it's not a y. X goes right and left. And when x is left like that, we're going further back into our number, so that's less than. And we're going to leave it at a less than. No line underneath the symbol because it's not less than or equal to, it is a dashed line. So just x is less than 7. And again, the only time I ever want you to think left and right is when it is just a single x. If it's a y, we're always thinking up and down to decide our shading. Okay, so that is graphing inequalities in a nutshell. And that should be it for tonight.